cat here for some more binary. We're still looking at conversion, and I'm quickly going to look at conversion of binary with a fractional part. So if we've got a decimal point, we might have something like 0.110. After that, how do we deal with it? How do we convert from binary to decimal and also decimal to binary? Let's have a look. Just like our normal conversions, we work with the same scale, except now I've got more items in it. So everything to the left, we saw before, it starts at 1 and you double everything to know the value of the column. Now to the right, we halve everything, so we divide it by 2. So half of 1 is 0.5, half of 0.5 is 0.25, and so on. And we complete our conversions in much the same way. So the number I gave you on the previous slide was 101,110. I gave you 110. For the same token, those remaining ones are also zeros. So let's have a look at how we would calculate this one. So I always do my whole number separate from my fractional number. So I'll put little dots there. So 4 plus 1 is equal to 5. Now let's have a look at the fractional part. We've got 0.5 and 0.25. Now in adding these up, I always put them in above each other in columns because I find that for myself it is easier to add up. So if I add 0.5 and 0.25, basically there's a 0 at the top there, so 0 and 5 is 5, 5 and 2 is 7, so it is 0.75. That means that my conversion is 5.75. Let's try that with a different one. Okay, because we're mostly focusing on the fractional part here, I'm just going to put in some random numbers. So let's go 0.01011. So again, I separate how I look at the 2. So a 2 and a 1 is 3 in the whole numbers. And separately, I'm going to look at the fractional part. So I've got 0.25, I've got 0.0625, and I've got 0.03125. So make sure you line everything up in the appropriate columns. So adding those up, I've got 5, nothing above it. I've got 5 and 2 is 7, nothing above that one. 2 and 1 is 3. 5 and 6 is 11, plus another 3 is 4, carry the 1, so it was 14. 1 and 2 is 3, plus 0 remains 3. That means that my final solution for this one is 3.34375. Now let's say I had to work the other way and I start with a decimal. So I'm told that I need to calculate 7.25. So I would do my conversions in the normal way, and I've given myself a very small scale here, but anyway, I separate the 2 and I work with my whole number first and my fractional part second. Does 4 go into 7? It does, and 7 take away 4 leaves me with 3. Does 2 go into 3? It does. 3 subtract 2 is equal to 1. Does 1 go into 1? It does. So that's our 7. Now let's look at our fractional part. I'm going to do this the cheats way first, and I'm going to look, does it line up perfectly with something that already exists? 0.25 is an option already, so I put one of those and put all the remaining ones as 0. Now that we're okay with that, let's try one that's slightly harder. Okay, let's say we were given the value 2.75. I'll focus on my whole number first, and that is no 4s, a 2, and no 1s. Now let's look at the fractional part. And I can do some basic maths here, and what I say to myself is, how does it compare to 0.5? Well, it's bigger than 0.5. So the first thing I do then is I try adding 0.5 to the next one in the list. And lo and behold, 0.5 plus 0.25 is equal to 0.75. So I put a 1 in there, a 1 in there, and the remaining ones are 0. I use this approach when it looks like it fits easily into that scale, and I'll attempt it by adding together different components and seeing what result I get. Let's try a harder one. So let's say I was given 1.3125. Let's do the easy part first. We've got 1, 1, 0, 2s, 0, 4s, and we're just looking at the fractional part. Now how does it compare to 0.5? Well, 0.3125 is lower than 0.5, so we can't have any 0.5s in there or the number is too big. Compare 0.3125 to 0.25. The 3125 is bigger than 0.25, so we do need one of those. So we could do 3125 minus, so 0.3125 minus 0.25, and I'm a little bit lazy for that. So what I would do is I would actually just try and add together 0.25 to 0.125 and see what I got. I got 573.375, and that number is too big, so it's not that one. So I'm going to try with the next one, 0.0625. So I'll find some space on my page, and I'll take 0.25 and I'll add 0.0625. The 5, the 2, 5 and 6 is 11, 1 carry the 1, and 3125. So it's that. Now do be careful. I gave you 0.3125. The value of that last column there I've got is 0.03125. That 0 does have a meaning. It does hold a place value, so don't accidentally get it muddled with 3125. So using this procedure, you can figure out what the fractional part is of pretty much any number. Now, if they don't look like they fit easily into this scale, there is another approach to figuring out the fractional part, and we'll have a look at that now. So let's say we had the number 0.4. Now that doesn't look like it easily fits into a 0.5 or a 0.25 or a 0.125 or whatever, so we're going to take this other approach. And the way that we do this is we repeatedly multiply by 2. Okay, now that gives us two parts. It gives us the whole part and the fractional part. So 0.4, 0 is the whole part, the 0.4 is the fractional part, and I'm going to separate those out into two columns. So I've got the 0 and I've got the 0.8. So 0.4 times 2 is 0.8. Now I leave that 0 there and I take my 0.8 across to the next row. I multiply that by 2 and that one will give me 1.6. So these are basically separated by decimal points. That gives me 1.6. Now I leave that 1 there and I take the 0.6 to my next row and I multiply that by 2. That will give me 1.2. So again I leave my 1 there and I take my 0.2 to the next row. 0.2 times 2 is equal to 0.4. And I leave my 0 there and I take my 0.4 and I multiply it by 2. 2 lots of 0.4 is 0.8. What we're going to notice here is that it is actually a recurring number. So when we looked at that scale, if we'd got 0.4 and tried to figure it out the slower way, we would have been there for a very, very long time. So this way is actually more efficient for a lot of the numbers. If it doesn't stand out to you as a basic solution, use this multiplying method. I'm going to stop there because I know it's recurring and I could just continue forever. What I'm looking at is this part here. So my number 0.4 was actually 0.01100. So by doing the multiplying out, you are actually finding out what the binary conversion is, but by multiplying it out. And the number that you produce by separating off the whole numbers, whether they're zeros or ones, that actually forms your binary. So you read it from top to bottom as if it was left to right. So let's just do another quick one to practice that. So let's start with a more challenging number. We're going to start with 0.13. So we look at that. We would start off by looking at our scale and saying, does it fit easily into 0.5, 0.25, 0.125, and so on. It doesn't quickly appear to me, so I'm going to use the multiply method. So I see 0.13, I multiply it by 2, and that produces 0.26. I keep my 0.26, multiply that by 2, and that is equal to 0.26. 0.52. 0.52 times 2 is equal to 1.04. Then I leave my 1 behind, I take the 0.04, multiply that by 2, and I get 0.08. I take my 0.8 and I multiply it by 2, and I get 0.16. My 0.16 times 2 is equal to 0.32. 0.32 times 2 is equal to 0.64. 0.64 times 2 is equal to 1.28, and we might stop there. With any of these types of conversions, you need to decide a point when you will stop. Okay, there is no set rule. If you've done a few multiplications and it finishes with zeros, then that's fine. But a lot of the time you'll find that they do continue. You just need to set yourself a finishing point. I would usually do 5 lots of multiplication before stopping. In this case, I just kept going a little bit more. Okay, so this is my solution. So it's an incomplete solution. It's not quite 0.13 because we didn't keep going until we got to zeros, but roughly it is 0.00100001. Okay, so there were 4 zeros there, double check. Okay, so that is how you would convert a fractional part. Good luck in your conversions.